Hola, ¿cómo estás? Me llamo Señora Kranz. And I'm going to talk through question 8. I'm going to talk through B and D because I've asked you to do A and C. Now, this is really weird. We've never factorized something with quartics before, with x to the 4 before. But we know how to factorize stuff with quadratics, with x squareds. So what we're going to try, or anything squared, so we're going to try and turn it into something like that. So for 8b, we've got 4x to the 4, take 13x squared plus 9. Now we're used to factorising stuff that looks like ax squared plus bx plus c. So I'm actually going to be like, well, this would be much easier if instead of x squared I had like x, but I can't use x because it's x squared. So I'm going to say let u equal x squared. Then this is 4, well x to the 4 is x squared squared, so that's u squared. Take 13u plus 9. And now this is something I can factorise. I can factorise it quite easily. So 4 times positive 9 equals positive 36. What multiplies to get positive 36 and adds to get minus 13? 12 and 3, no. 9 and 4, 9 and 4. So minus 9 and minus 4. So I rewrite it, 4u squared take 9u take 4u plus 9. And that becomes u outside of 4u take 9, take 1 outside of 4u take 9, which gives me 4u take 9, u take 1. So I've factorised it to be 4u take 9, u take 1. And now instead of u, I could use x squared. 4x squared take 9. X squared take 1. Now, you'd think we'd be finished, but we're not, because now I say that this is in the form a squared take b squared. So I can do each of these as a take b, a plus b. So for example, 4x squared take 9. Well, that's the same as 2x all squared take 3 squared. So that's 2x take 3, 2x plus 3. So that 4x squared take 9 became that. X squared take 1, well that's x take 1, x plus 1. So I'm going to do that green. So that became that. And finally, I've factorised. So my zeros are positive 3 on 2, negative 3 on 2, positive 1, negative 1, and they're all multiplicity 1. They're all simple. My y-intercept, let x equals 0. I've got y equals 4 times 0 to the 4, take 13, 0 squared plus 9. It's obviously going to come out as 9. So now let's sketch this thing. Oh, behaviour, sorry. Behaviour as x tends to negative infinity. So I'm going to choose x equals, what's smaller than any of these? Well, minus 2. Y equals 4 times, oh, actually I'm going to sub it into the last one. I think that'll be easier. 2 times minus 2, take 3. 2 times minus 2 plus 3, minus 2 take 1, minus 2 plus 1. So this is a negative times a negative times a negative times a negative, which gives it makes it a positive. So now I can actually sketch it. Again, we're not doing a great job on this. So I've got minus 3 on 2 and minus 1, positive 1 and positive 3 on 2. And down here we're going to start off, this came out as positive, so we're up here. And they're all simple roots, so it just kind of cuts through them. Yeah, it's not going to look good. My y-intercept is 9. That's how it's going to look. For 8D, we have a slightly harder process. Let me copy this question. Actually, I'm going to do it down here. We're going to need a lot of space for this one. Okay, this time I'm going to say let u equal x squared take 3x plus 1. Then I've got p of u equals u squared take 4u take 5. And I can factorise that. What multiplies to give negative 5 that adds to give negative 4? U take 5, u take 2. Which means instead of u, I had x squared take 3x plus 1. So I'm going to rewrite that as x squared take 3x plus 1 take 5. X squared take 3x plus 1 take 2. So that was those. X squared take 3x plus 1 take 5 is the same as x squared take 3x take 4. And this one's going to come out as x squared take 3x take 1. Now, this first one on the left, yeah, that's the same as x take 4x plus 1. This one on the right, let me quadratic formula this one. So I've got x squared take 3x take 1. X equals minus negative 3 plus minus the square root. So if I can't figure out how to factorise it in my head, I'll always go to the quadratic formula. Negative 3 squared take 4 times 1 times negative 1 all over 2 times 1, which gives me 3 plus minus the square root of what? 9 plus 4, 13. Over 2, so I've got 3 take root 13 over 2 and 3 plus root 13 over 2. I don't have my calculator. So then that's what x equals. Don't forget I've got to change the sign to put it back into brackets. So I've got x take 3 take root 13 over 2. And let me move this out of the way a bit. X take 3 plus root 13 over 2. Okay, now y-intercept. X equals 0, y equals negative 4 times negative 1, positive 4. And behaviour as x tends to negative infinity. Well, we'll choose a number less than any of these. I don't actually have a calculator, so I'm just going to choose like minus 10 to be safe. X equals minus 10. Y equals minus 10 squared take 3 times minus 10 take 4. Minus 10 squared take 3 times minus 10 take 1. 100 take plus 30 take 4. 100 take 30 take 1. So it's a positive times a positive. So it's a positive. Okay, now we can sketch. Not going to do these accurately because I don't know what 3 take root 13 over 2 is. But I've got positive 4, negative 1, well, root 13 between 3 and 4. I'm just going to pretend it's there, and I'm starting off positive. So it's going to, like that, or something. That's question 8.